Okay, it is day 22. We are on unit 3 in geometry, and we've been learning about quadrilaterals and finding area and perimeter. We've looked a little bit at angles as well, but today for your do now, you are going to be finding the area and the perimeter for each quadrilateral below. And I put a challenge question on here. For number 4, we have finding the area and perimeter of a triangle. Now notice we have a missing side length here. So you're gonna need to go back in your notes if we don't remember how to do that. And we're gonna solve for this missing length here. So I'm gonna have Gina set a timer, and I'll give you about 15 minutes to work on this. We'll pause the video, and whenever we come back, we will look at the answers together. Okay, we're back. All right, so let's look at number 1. So, first of all, number 1, what kind of shape is this? Ooh, it could be a rhombus. Now, with a rhombus, we need all 4 sides to be the same length, don't we? Yes, so this will be a parallelogram. This will be a parallelogram. I'm gonna grab my pen and let's look at the area first. So whenever we're solving for area, which 2 numbers should we be using?
The length and the length and the width, but length and height.
Yes, so normally with a square or a rectangle, we're used to saying length and width. But with a parallelogram, we've got 3 values to choose from. So we really need that bottom length or that base, and then we're gonna use the height as our width. So we'll take 12.5 times 8. And let's see what that gives us. You tell me if you got the same answer as me. 12.5 times 8. 100. Oh man, I accidentally gave you a nice pretty one. Okay, 100. And what would our units be?
Inches squared.
Yes, inches squared. Beautiful. I'll circle that. Perfect. And now how are we going to find the perimeter?
When you do the 12.5 times 2,
Mm-hmm.
and then the 9.2 times 2.
Yes, perfect. So we're just trying to find the total length around the whole shape. So we know that these sides are the same. We've got 12.5 times 2. These sides are the same, 9.2 times 2. We could do them separately, or we could also use that formula for the perimeter where we write 2 on the outside since we're multiplying both numbers by 2. And then we could add these in the middle. Now, I think some people find this a little bit unnatural, writing it in the formula way. And if so, that is totally fine. You could just do this, like you said, and you'll get the same answer. So let's see. I'm going to work that math out. 12.5 plus 9.2. 43.4, perfect. All right, and what are our units? Perfect, inches. 43.4 inches. Excellent. All right, let's look at number 2. Number 2, I only gave you 1 side length, so you got to use some context clues to figure out the others. So first thing here, how do you figure out all the other side lengths?
They're all the same.
They're all the same. You can see they've all got that single dash, that tick mark. So how am I going to find my area?
13.7 times 2.
13.7 times 2?
Or is it times 4?
So if I did 13.7 times 2, I would get this length plus this length, or one of these. If I did it times 4, I'd be getting the perimeter. But remember, with area, I want to find everything inside. So whenever we did the parallelogram, we took the base, the bottom side, times that width or that height. Is my width 2?
Oh, 13.7 times 13.7?
Good. Yes, we want to do side times side. 13.7 times 13.7. Super common mistake. You could also, since it is a square, you could do 13.7 squared. You'll get the same answer. And when you work that out, you tell me what you get.
I got 187.69.
Perfect. 187.69. And what's our units?
Inches squared.
Perfect. Inches squared. Excellent. Okay, so now how do we find the perimeter?
So the 13.7 times 4?
Yes, 13.7 times 4.
Which is 54.8 inches.
54.8. Perfect. Awesome. Wonderful. Okay. Let's look at number 3. So what kind of shape is this?
I feel like I'm gonna be wrong. It's not a rectangle.
It's a rectangle.
Okay.
Perfect. It's a rectangle. I know. I feel like everybody gets nervous when I ask them the easy ones because, like, ain't no way. It's got to be something trickier. Nope, it's just a rectangle. So, how are we going to find the area of this rectangle?
So I did 53.2 times the 23.1.
Perfect. 53.2. Is that purple too hard to see? It's kind of light.
When it starts to dry, you can see it.
Oh, really? It does kind of darken. I'll just switch. I'll switch. 53, that's a lot better. 0.2 times 23.1.
It's 1,228.92.
Woo, that is a big number. 1228.92.
0.92.
Perfect.
Inches squared.
Inches squared, amazing. Awesome. I'll circle that. And how do we find the perimeter?
I did the 53.2 times 2.
Mhm.
And then the 23.1 times 2. I'm not gonna lie, I always have to write it fully out.
And you know, sometimes that works better because whenever you know what you're writing and why you're writing it, I think that you're going to always do a better job and get a more accurate answer than trying to plug into a formula you don't understand. So I see nothing wrong with that. 2 times 53.2 plus 2 times 23.1. And let's see what that gives us. 2 times 53.2 is 106.4.
152.6.
Oh, perfect. 2 times 23.1. 46.2. Are these the numbers you got to start with?
Mm-hmm.
Okay, and then you just add them together. So plus 106.4. 152.6 inches. Perfect. Perfect. Okay, so now we have the challenge. So I'm going to grab an extra little sheet to write some of our work out because I didn't give you a whole lot of room on here. So we need to find the area and the perimeter of this triangle, but we are missing one of our side lengths here. So there's 2 ways that we could find that missing side length. What's one way we could find it?
You literally just told me.
I did just tell you.
I do know the formula.
What's the formula?
A squared plus B squared equals C squared.
Perfect. We've got a squared plus b squared equals c squared. And that's because this is a right triangle, so we could use that. Let's try doing it that way first. Let's see if we get the same answer we got earlier. So our A and our B, which sides do they have to be?
The A has to be the bottom one.
This one?
Yeah.
Could be that one, absolutely. Now, what about B and C?
Okay, so my B was the one we didn't know, and C was the 10 inches.
Perfect, that works. So A and B could be either of these legs. C has to be the hypotenuse, the longest side. So you said you made this the shorter side B?
Mm-hmm.
Okay, so we'll make this A squared. So we'll do 8.66
Plus 5 squared.
squared plus, and I'm going to put B squared for now since I'm going to pretend we don't know it yet. Plus B squared equals 10 squared because that's our C. Okay, so now let's kind of solve this out together. Let's find 8.66 squared. I'm going to type that one in. 74.9956. Did you get the same thing? What did you type in?
I didn't remember how to put the square.
Ooh, okay, so good little mini lesson. We can type in, let's type in 8.66. 8.66. And to square a number on your calculator, it'll be directly across from the 7 to the left side. There'll be a button that says X with a little 2 above it, X squared. And you just push that after your number and it's squaring it now.
Okay.
And there we go. So I'm going to write 74.9956. We don't know B yet, so plus B squared equals, and what is 10 squared? 100. Perfect. 100. Okay, so from here, what do you think I need to do next to get us closer to solving for B?
Divide 2 from the B squared and 100.
We won't divide the 2. We can't separate B squared yet.
Subtract 100 from both sides.
So if I subtract 100 from both sides, I'll have a number plus B squared equals 0. Does that help us? There's one more option you haven't said.
Add it.
Just kidding, there's 2 more options you haven't said.
I'm having a brain fart.
That's okay. So we're trying to get B squared by itself on this side of the equal sign, right? This is the number that's keeping B from being by itself, so we want to get rid of it. How would I get rid of a positive 74.9956? It says plus that number here.
You would subtract it.
Yes, we're just going to subtract it. That'll get rid of it. Minus 74.9956. We'll do that from both sides. Okay, so we just need to do 100 minus 74.9956.
I got 25.0044.
Perfect, that's what I got too. So these cancel out. And I'm left with B squared equals 25.0044. And since we've got 25.00 as the first 2 decimal places, let's just get rid of the decimals for now. And that's going to give us a nicer answer for B. So, do you remember from last unit what the opposite of squaring a number is? How would I get rid of that squared on the B? And I'll give you a hint. On your calculator, when you look at that squared symbol, there's a little blue symbol right above it that's going to tell you what to do.
Square root it.
Yes, we're going to use the square root. So square root is the opposite of squaring. So if I take the square root of b squared, it gets rid of the squared. If I take the square root of 25, we're going to find our answer for b. So I'll have b equals, and do you remember how to type in a square root?
Is it the second? And then
Yes. So we'll hit second x squared. So now we've got our square root. And then we type in our number, and it's 25. 5. It worked. That's what we got in the other way. So now we finally have our missing side. That took forever. The faster way that I showed you earlier would be, if we don't want to mess with the Pythagorean theorem, since this is a special right triangle, a 30, 60, 90, we could look back in our notes and see that this side length across from the 30 is x. This side length across from the 90 is 2x. This one we don't really need, so we're just going to look at these two right now because we've already got the answer for this. It's 8.66. So if I know that 10 inches is 2x, we could set up an equation. 10 equals 2x. And then exactly what you did earlier. To get x by itself, we divide by 2. And then 10 divided by 2 is 5. That was a lot faster.
Yeah.
A lot faster. So it helps to know those special triangles. It'll kind of come in handy.
I like the bottom one.
Yeah, take your time. I probably ought to slow down a little anyway. My fourth period, people watching this, I'm sure y'all are wanting me to slow down too. And you just tell me when you're ready. Perfect. Okay, so now we have all three side lengths. So how are we going to use those to find our area and our perimeter?
I added the 8.6 and the 10 inches on the 5.
Perfect. And that'll be, is that area or perimeter?
Perimeter.
Perfect. So let's do that. 10 plus 5 plus 8.66.
23.66.
Yes. 23.66 is our perimeter. What's our units?
Inches.
Inches. Good. And how do we find the area? This is different than the quadrilaterals.
Okay, I'm not gonna lie, I got 43.3 inches squared, but I don't remember how I got it.
Huh. Okay. Well, let's work it out and see if it's right. So I haven't solved this one yet. Oh, I think I know what you did. Did you do 8.66 times 5?
Yeah.
Okay.
It's 22, I think.
Times 10?
I think I multiplied all three.
So if you did it times 10, you would have gotten about 400 something.
You're right, I did the 8.66 times 5.
Yes, so you are very close. I'm going to show you something. Fourth period saw this. You guys, first period did not yet. I didn't teach you this. That's why it's a special extra challenge. So if I wanted to find, I'm going to draw an imaginary other triangle right on top of this one. If I wanted to find the area of this whole shape of both triangles, I would do 5 times 8.66. That's going to give me the full area of this rectangle here. Now, how big does it seem like this triangle is in comparison to the whole shape here? Like, if I were to give a percentage or a fraction, does it look like it's about 3/4 of the size, half the size?
It looks like it's the same size.
Yes, so these two are about the same size, right? So if these are the exact same size, then this one right here must be half of this rectangle, right? So if we found the area of the rectangle by multiplying these two numbers together, we could just take the number you found and divide it by 2, since we're really only finding half of a rectangle. So the trick with triangles is that we just remember that a triangle is like half of a rectangle or half of a square or whatever shape it ends up being. So you are going to take 5 times 8.66, and what was the number you said you got? 43.3. And that 43.3, I'll give you a little visual. 43.3 represents all this. So we want just the pink part. We want half of that. So we can just divide it by 2. And let's see what that gives us.
21.65.
Perfect. That's exactly what I got. So our area, I'll leave that up for a second. Our area is going to be 21.65. And what's our units?
Inches squared.
Inches squared. Perfect. Perfect, perfect. All right. I'm going to pause this really quick. Okay, so that is our do now. Let's go ahead and put that to the side, and we're going to get our notes out and start a new page. So I'm going to put that over here. And I'm going to go ahead and title it today. We've got geometry. Unit 3. And update on Unit 3. Our plan as of right now is on Monday. So today we're probably going to cover the rest of the unit. Monday we're going to do a practice quiz. Tuesday we'll take the quiz. Then we're moving on. So.
I'll be at work.
Ah, you'll be at work.
Yeah.
Okay. So here, let me pause this and we can talk for a second. Okay, back to it. So this is, our do now was page 1. This will be page 2 of our notes. And we are on day 22, right? 22 continued. Okay, so let's look at the handout that I gave you, this one with all the polygon names on it. So we have been learning about triangles, we've been learning about quadrilaterals. Now there's a whole bunch of others here. So let's just talk briefly about what we know about each one. So in terms of area and perimeter, we've learned that a triangle, to find the area, we've got a base length here. So base, and the up and down is our height. And to find the area of a triangle, we were doing base times height and then dividing it by 2 since it's half of a quadrilateral. So we could write that formula as 1/2 base times height, and I'm going to write B and H. Or you could write it as base times height divided by 2, since that's how we usually end up actually working it out. Either one will work. And then the perimeter, we know we're always just adding the sides together. So perimeter is side plus side plus side. And I probably should be using some colors. So base or side, depending on the type of triangle. Okay, so let's look at the quadrilateral, and let's do some labeling here. We'll call this here our height. Even though we would normally call this a side length, we know that we want to focus more on height rather than side lengths because of like parallelograms. You know, we don't want to use the side to find our area. We want to use the height. And this is our base again. So how do we find the area of a quadrilateral? Base times height. Perfect. Base times height. And then our perimeter, same thing. You're adding all the sides together. So side plus side plus side plus side, depending on what the side lengths are. Okay, and I guess we could label our sides again. So we've got 4 sides here. Now, as we keep going to our shapes with lots and lots more sides, our formula is going to change a little bit. So here's how I'm going to have you label this. Let me grab, I made a little sticky note. I'm going to pause while I look for it real quick. Hang on. So to find the area of any other polygon, and remember, a polygon is just a closed shape made of straight line segments. So to find the area of any of the others, we're going to do area equals 1/2 times perimeter times a new word I'm going to teach you. It's called apothem. A-P-O-T-H-E-M. And I'm going to title this formula here, area of regular polygons. Okay. So, first of all, let's make sure we understand what I mean by regular polygons. So a polygon, like I said, could be any closed shape made up of line segments, but for a polygon to be considered regular, there's a few things that are required. So a regular polygon, I'm going to write this under here. Regular polygons have all side lengths that are the same. So all sides are equal. And all angles are equal. So to make sure that we are remembering that these are all supposed to be regular polygons, let's go through and label these with our congruency markers, where we draw arcs on the angles and we put little dashes on the sides. So let's see, I'm gonna get another color out. Let's start with our pentagon. So to show that all the sides are the same length, we're just gonna put little dashes on all of them like this. And then to show that the angles are the same amount of degrees, we put these arcs on them like this. So what I want you to do now is to look at your pentagon, and we're gonna take a straight edge, a ruler, and we're gonna draw lines going from each point, each vertex, from here to the middle of the opposite side. So I'm not asking you to make it perfect, but I'm gonna use my ruler first and see how long are these sides. Maybe I can get a good middle. Oh yes, they're all almost exactly 2 centimeters. So I'm gonna actually make a little middle marking at 1 centimeter on each of my sides. Okay, 1. And 5. Okay, and then like I said, we're gonna start from the vertex of each angle, and we're gonna go to the opposite side of the shape. So it'll look like this. There's one of my lines. We're going to do it with all 5 sides and all 5 angles. And you're going to end up with an intersection of a bunch of lines going into each other in the middle of your shape. There's another one. Here's another one. Here's another. And here's my last one. Okay. So by doing this, we'll be able to find the perfect center of the shape if we did it accurately. I'm going to give everybody some time to get their shape marked. Okay, you got yours done? Perfect. So here's where we're going to talk about that new word, apothem. So the apothem is defined as the length from one side, from the middle of that side to the very middle of our shape right here. And it's always the distance going at that 90-degree angle. So I'm going to label this apothem. So the apothem is always going to be that little section right there from the middle of a side to the middle of the shape. Perfect. So knowing that this is the apothem length, it won't be something I'm going to have you solve for. It'll be given to you. But this is just so we know how to identify it. So we use the apothem and we use the perimeter to find our area. So let's move this to the side, and I'm going to give you an example. So a pentagon is a shape with 5 sides. So I'm going to say I have a pentagon I'm going to actually say I have a regular pentagon. So I know all my sides are the same length and all my angles are the same measure. And I'm going to give you that one side is 5 inches. And I'm going to give you that the apothem is 7 inches. Now, you totally don't have to draw a picture, but I'm going to try to. I don't know that I can make a pentagon all that well, but I'm going to try. So I need 5 sides. 1. Let's see. 2. Oh no, I think I made my angles too wide. 3. Oh yeah, that's gonna be bad. That's okay. That's okay. I need a visual. Pretend these are all the same length, even though it doesn't look like it. Okay, so I just stretched it out a little too much. I'm gonna mark my sides and my apothem. So let me get a color. Do green. So my side, all my sides are the same. And I know my side length is 5 inches. And then the apothem that I gave you is going to be 7 inches. So here's the visual. So if I wanted to find the area, I would need to find the perimeter first. So how would I find the perimeter of this pentagon?
Use the formula we just got.
So perimeter first.
Oh, sorry.
No, you're okay, you're okay.
Perimeter. Isn't that the 5 plus the 5 plus the 5 plus the 5?
Yes. So there's 5 sides on this pentagon. Each side is 5 inches. We could do 5 plus 5 plus 5 plus 5 plus 5.
5 times 5.
Or we could do 5 times 5. Yes, perfect. So 5 times 5. And what is that going to give us for our perimeter?
25.
25 inches. Perfect. Okay. So I'm going to rewrite that formula. Area equals 1/2 times perimeter. I'm going to write that as P times A apothem. Okay, so let's use that. So for area, I've got 1/2, let's just plug values into the formula, times, what's our perimeter? 25, good. 1/2 times 25 times what? Perfect, times 7. Okay, and remember, just like with the triangle area formula, if it feels easier to do it like this, 25 times 7 divided by 2, these are the same. Taking something divided by 2 or times 1/2 will give you the same answer. So let's type that in and see what we get. Okay, so 25 times 7, we get 175. Yes. What's that give us? 87.5. Perfect. And what's our units? Inches squared. Yes, yes, perfect. Wonderful. Okay, so we can use this formula for any shape at all, as long as it's a regular polygon, depending on the side length. The only thing that's going to change here is how we find the perimeter. Instead of taking our side times 5 for a 5-sided shape, a pentagon, what if we had, let's look at our little paper I gave you. What if we had a dodecagon? Whew. I know it. These are some crazy names. Somebody got really creative when they made them. So actually, before we do that, let's go through all of these. Let's just introduce these names and make sure we know how to pronounce them. So we have our triangle, that's 3 sides. We have our quadrilateral, that's 4 sides. We have our pentagon, that's 5 sides. Hexagon is 6 sides. Now this is normally where our knowledge stops, is that hexagon. Or the octagon, some of us know octagon.
So I know that one, but then it's like, I've never heard of the heptagon.
Right.
Or the octagon, but nothing after that.
Yes, so these are just very uncommon shapes. You don't typically see a 7-sided shape or anything more than the 8-sided shape. So, you know, they exist though. They exist. So we have a heptagon. We've got the octagon for 8 sides. 9 sides is nonagon. 10 sides is decagon. 11 hendecagon. And 12 is dodecagon. Now, I wish they would have just done this after 8 or so, but anything above 12 sides, we call it, here I'll write this, more than 12 sides. We call it an n-gon. And when I say n-gon, n is actually a variable. N is going to stand for the number of sides. So if I had a 13-sided shape, it would be called a 13-gon. Pretty creative. A 14-sided shape would be a 14-gon. And I think that might just make everyone's lives easier if we just did it that way. But you know, it is what it is. So that's what we got here. Let's actually use that n-gon idea and let's find the area of something else. So what if I gave you a 20-gon? Yeah, 20-gon. And on this 20-gon, our side length is 3 inches. And let's say our apothem is, I can't even picture how big that would be. I feel like it would be much bigger. I'm gonna go with, my goodness, I don't know, 12 inches. That's probably way off, but the math will still work. So, let's walk through this one together. First of all, how would I find the perimeter?
So it would be the
Yeah, so how many sides does a 20gon have?
20.
20.
3 times 20.
Exactly, 3 times 20. So for perimeter, we're gonna do 3 times 20. 60. Perfect. So our perimeter is 60 inches. The perimeter is not so bad. So now, let's find the area. So remember, to find the area, what numbers are we going to be using?
The 20 and the 3.
The 20 and the 3. So we used those to find the perimeter. Let's look at our area formula up here.
Oh, the P and the A, so the perimeter and the area, so
The perimeter and the, what's that new word we learned?
apothem.
Apothem, yes. So we need perimeter. What's our perimeter?
60.
Perfect. 60 times our apothem, which is what?
12 inches.
12. Perfect. And then we divide that by 2. So let's find that. So what's 60 times 12?
720.
Perfect. Yep, then we'll divide by 2.
360.
360. And inches squared. Perfect. Amazing. Amazing.
Well, it's not so bad.
Yeah, it's not so bad. Well, it's really one of those things where it's something that's unfamiliar. We're learning it, we practice it once or twice, and then it's like, oh, that isn't so bad. Okay, so here's what we're gonna do next. We just did a few examples together, and now I have a worksheet that I'm gonna have you work on. And it's gonna look like this, so I'll put it on the camera and then I'll bring one to you. We are going to be finding the area of regular polygons, meaning they're all the same sides, all the same angles. And anytime that you see the number inside the triangle or inside whatever that shape is, I don't know how many sides it's got, that's the apothem they're giving you. Now, on this worksheet, they're giving us some funky numbers like this.
Yeah,
So, real quick walkthrough. If I need to know what the apothem is, I have this here. I'm just going to type it in my calculator. So, I would type in 4, and then that second radical button, or the square root, 3. Just how it says, and we'll do the fraction part next. So, enter.
big number.
Yep, big number, 6.9 something. And then we just divide by 3 like it tells us. Divide by 3. And so this would be our apothem, 2.3. We'll just go with the first decimal place, 2.3. And you'll just use that in your formula that I gave you, that apothem times perimeter divided by 2.
Okay.
So I'll go ahead and write the value on this one. That apothem is 2.3. Okay, now this worksheet doesn't have any units, so you actually don't need to write inches squared or anything. You're just gonna give me the number value. Okay, does that sound good? Any questions about it? Okay, perfect. So I'm gonna pause this, pass this out, and we will look at some of them together in a moment. Okay, we are back. Let's look at number 1. So before we get started, I'm gonna rewrite that formula at the top of my page because I'm gonna forget it. So I know area equals, you could either do perimeter times apothem divided by 2 or 1/2 times perimeter times apothem. I'm going to write it divided by 2 because I feel like that's how we usually do the math anyway. So perimeter times apothem divided by 2. Okay, so number 1, what is your perimeter here? Yes, 8 times 3 is 24. So I'm going to go ahead and start writing my formula. Area is perimeter, so 24 times apothem. What's our apothem?
2.3.
Good. 2.3. Then we'll divide by 2. And let's see. 24 times 2.3.
55.2 divided by 2.
Good. 55.2 divided by 2. And what'd you get?
27.6.
27.6. Let me double check. Yes, that's what I got also. Perfect. 27.6. And I know I told you that since there's no units, you don't need to write anything other than the number, but I kind of forgot that I guess when you don't have labeled units, we just call them units. So if you wanted to label it, you could say units squared. And I will circle that. That's our answer. Perfect. Okay, let's look at number 2. How many sides does this one have?
8.
Okay, here, let's count. 1, 2, 3, 4, 5, 6, 7. This one's just got 7.
And I literally wrote 7.
That's okay, that's okay. So how do we find the perimeter first?
13.9 times 7.
Good, 13.9 times 7. Let's see what that gives us. 13.9 times 7.
I got 97.3.
Perfect, 97.3. So we're going to put that in our formula, 97.3. Good, times 14.4 divided by 2. So let's see, 97.3 times 14.4.
1,401.2.
Perfect, 1,401 point, yeah, 0.12. Is that what yours was?
Yes. Oh no, we're not doing
Oh my gosh, you're okay, I promise. It is okay. It's Thursday. It's the last day of the week for us. So now we divide that by 2.
I got 700.56.
Perfect. 700.56 units squared. That is our answer. Wonderful. Okay. Number 3. How many sides do we have?
8.
1, 2, 3, 4, 5, 6, 7, 8. Yes. So how do we find the perimeter?
12 times 8, which is 96.
Perfect. 12 times 8, which is 96. Okay, so let's find our area. We'll do...
Can I say it?
Yes.
Okay. 96 times
96 times 14.5, perfect, divided by 2. All right, and what's our top number when you multiply?
1,392.
Some big numbers today. 1,392 divided by 2.
Which leaves you with 696 units squared.
Perfect, 696 units squared. Amazing. Okay, last one. How many sides does number 4 have?
5.
5. So how do we find that perimeter?
7.5 times 5.
Perfect. 7.5 times 5. What did you get?
37.5.
Awesome. 37.5. And you tell me how we find an area.
Okay, 37.5 times your 5.1 divided by 2.
Perfect. 37.5 times 5.1 divided by 2.
Gives you 191.25. And then divide that.
Yes, 191.25 divided by 2.
Which gives you 95.625.
Amazing. 95.625 units squared. Perfect. Okay. I think you got this. Definitely, you got this. So we are a little over our time. It is 10:26, 27 now. So if you have another class to get to, you're welcome to go. Number 5 and 6 on this worksheet is going to be our day 22 exit ticket. And that will be due on, let's see, it's Thursday. That'll be due next Thursday on December 19th. So let's write that in. Exit ticket. Due December 19th. Nope, not 19th. Sorry. December 12th. December 12th. I was looking a week ahead, and that's a Thursday. Okay, so that is all today. On Monday, we will be doing that practice quiz, and Tuesday, we're going to take the quiz. So I'm going to end the video here, and y'all are free to go or work on your ticket.